Today we are going to go on this adventure with Alice to the world of pods and higher order functions again. And this time we are going to concentrate more on the practical side of connecting Kubernetes and Scala. So as I said before, as it was said before, I work as a data developer at Captify. Captify is a British company working in the ad tech industry. And currently, it's the largest independent holder of user search data outside of Google. The engineering team is divided between Kyiv and London, and I'm based in Kyiv. Also, I'm diversity inclusion ambassador for the Kyiv office, Women Who Code Kyiv data engineering lead, mentor, and I love speaking and traveling. So first, small disclaimer in the beginning that there's going to be a set of examples, but I'm not going to share like the whole setup of the project with dependencies and so on. We are going to concentrate more on specific functions. So feel free to check out later the repo, which is going to be in the next slides, to see the examples and how it works all together, just to set it up. So in the previous episode or talk, so actually this talk is the continuation of the talk I did once about Alice traveling to the world of pods and higher order function, where she learned about the connection between functional programming and Kubernetes. So in order to kind of grasp where we are now, I'm going to make a small recap of what happened to Alice on her previous adventure. So the first place she visited was a functional forest, where she learned about the functors and monads and how they look like and how they work like. And the next place was a default namespace city. And these two parts of the world were connected by this small bridge, which was breaking down. But in reality, the connection in terms of the sense was much stronger than that. So in this default namespace city, Alice saw that all of the buildings looked like constructor details, and actually it was one of the features of this part of the world. And they constituted a type system, and also they were immutable, same as monads and all the objects she met in the functional forest. So over this trip, she managed to make conclusions regarding the similarities between Kubernetes and functional programming. And first being a type system for Kubernetes, that would be the objects which you create like pods, deployments, and so on. Another feature would be immutability. So in functional programming, we work with immutable objects where we need to recreate it if we want to update something. And same in Kubernetes. If we want to update, for example, the deployment, we would have to create a new one. Another one is declarative nature, which means that we have some kind of desired state of the system, and we have a way to track whether our actual state of the system matches the desired state. So in Kubernetes, multiple controllers work to kind of support that. And in such a way, we can provide the number of objects we want to create, the types of objects, and each time these controllers would be checking whether the system is in the desired state. And if it's not, basically something is going to work behind the scenes so that would match our desired state. And we will see a bit later how it works in practice. And another aspect is DSL or domain-specific language. And for Kubernetes, that would be YAML files, because we just have to learn how to operate with all those options. And for functional programming, that could be a programming language like Scala. It can be a specific construct for the frameworks or libraries that we use. So Alice learned during this trip how to create pods, deployments, replica sets, even custom objects. And she created this magic database with multiple pods. And also she created a persistent volume, which looked like a safe lock. And this persistent volume was able to exist even if the database would be deleted in the future, because this is the nature of persistence for persistent volumes. So Alice put all the data, all the knowledge that she gathered over this trip into this persistent volume. And she didn't want to forget about this trip, so she decided to take the volume with her as well as a pod she befriended. So now we will skip to 2 years later. Over this time, Alice became a successful Scala developer. This trip actually inspired her to learn functional programming, to learn Scala, and she's been working as a Scala developer, but over some time she just got tired and decided to spend some time in the countryside to enjoy the nature. And she decided to visit her uncle's house. And basically, she didn't expect anything special to happen. She just had a very pleasant time reading, enjoying the nature. And on one of the days, Alice was walking in the forest around the house. It wasn't a scary place for her like the forest might be. Actually, it kept like lots of memories from childhood, which were very dear to her. And also it was interesting for her to like notice things that got changed over time, because she hasn't been in this house, in this forest for 2 years. So, and one of the interesting things that she noticed was this small cave, which was a bit like overgrown with some grass and trees around it. And she didn't even seen it before, and she couldn't remember if she did. So Alice is a very adventurous person. She's not scared of challenges, so she decided to check what's inside of this cave. So the first thing that she saw was the old computer, which was somehow a working machine. And also there was this safe lock, which was very familiar to her. And just to remind you that a few years passed and Alice like grew up a bit, and she forgot all the details of the trip, so she could remember just in general the events of this trip. So it reminded her of that adventure, but she couldn't connect it just yet. So on the computer, she could see the open terminal writing cave Kubernetes, and it meant for her that it's connected to Kubernetes somehow, and she wanted to see what's inside of this system. Maybe there are some objects that exist there already. So she typed classic kubectl get all just to see all the objects that existed in the system. And she saw persistent volume MagicDB, which was also familiar for her. But the most interesting feature was that it was 2 years and a few months old, and it matched exactly the time that she had her adventure. So she realized that it's definitely connected, and she decided just to make sure to look into it. So she put this describe command on the persistent volume. And indeed, she saw that the namespace was default, the naming was the same, and the persistent volumes was still running all this time. So while she was examining this persistent volume, she heard behind her back someone saying long time no see, which was really scary for her at first. But then she looked closer and realized that it was the pod that she took with her from her previous adventure, and she was very happy to see him. And also, she was kind of starting to feel ashamed that she completely forgot about him over this time, and she didn't know what happened to him. So the pod was quite lonely over this time, and he was keen to share his story with someone, and also kind of secretly hoping that someone might help him in this situation he found himself. So just when Alice took him from his world, they spent some time hanging out for a few weeks, and he was just curious to find out more about this human world he'd never been to. So he just went to the forest, and at some point he just got lost and didn't know how to find a way back. So he was lucky to find this small cave and decided to at least spend some time there, but eventually he just settled in. And luckily he was able to find this old computer, which made him hope that he could connect in some way to his home world. So also he took this persistent volume with him, which he tried to test somehow, but it didn't work for him. So Alice thought that maybe she could help him in some way, but she was not sure what she can do exactly. While the pod was wondering whether the power of Scala knowledge might help him, because he learned that Alice has become a Scala developer over this time. So Alice was really doubtful of that, but she decided to give it a try and at least like pretend that she's confident about it, that she can do this, because she saw that the pod was really desperate and lonely, and he wanted to come back home, or at least have some way to communicate with his home world, because right now he felt quite lonely and he didn't want to stay in this world for much longer. So Alice did something Scala developers always do when we start out, something we don't know. She decided to basically Google it. And what she found was a set of libraries she could use to connect Scala and Kubernetes. The first one was Java Kubernetes Client, which is an official client for both Java and Scala. But she looked at behind the scenes, there is a code generation for this library, and the API is quite limited, so she couldn't use much for her experiments and for her research. And also it was heavily written in Java with lots of examples, all in Java. Another library is Fabricate Io, which is not an official client, but it's quite popular. It's an open source library created by Red Hat community. And it's also written in Java, and all the examples are in Java, but it looked like much more extended in terms of API and the things that she could do with that. But it still wasn't exactly what she wanted. So she just looked into this small sKuber library, which was not very popular, but it was great for connecting Scala and Kubernetes instead of relying on the Java ecosystem. So she decided to try out this library and start with something very simple, just to see if she can even do something about it. So the first thing would be obviously to create some Kubernetes client, something to work with Kubernetes directly, and initialize it with the current context. And Alice was thinking what she can do just to try it out, some small experiment, quite reproducible, so she would be able to check if it works at all, and if there is a chance to actually combine this Scala knowledge and Kubernetes knowledge, of course. So she decided to try create a pod, just one simple pod. She defined this container, which looked pretty similar to the YAML way of creating objects. With the name, would it be just some test nginx, the labels, which would be useful for the future, and the template. And usually pods, they have the container definition, some metadata like name or namespace, and they may have labels or they may not have labels, but in this case, she just added them. And this is all just a definition, like a template for the object. In order to actually send the request to the Kubernetes API, she had to call create method on the client by providing the metadata needed, which is the name, and the specification and direct template description of the object, which is in this case defined in template value. So she hit kubectl get all, again, just to see what kinds of objects exist now after the creation of the pod, but nothing came up. And while Alice was thinking what could possibly get wrong, she decided that probably she needs to kind of reproduce it in some way. Maybe there was some glitch in the system. So she hit kubectl get all one more time. And indeed, the pod got created. Basically, Alice was a bit impatient, and it's been a while since she worked with Kubernetes, and she forgot that actually she needed some time to create objects in Kubernetes. Therefore, she needed to wait for some time until they are getting from container created to running state. And the MagicDB pod was really happy that at least he could find someone new, some maybe new friend from his closer kin from other pods. But Alice thought that it's kind of good, but not enough, because it's just a simple step, just a simple example, which proved her experiment that she can work with this library to create Kubernetes objects and do something about the situation of the pod, but it wasn't exactly the solution. So she decided just to delete this experiment, which was fairly simple with Kubernetes delete. And then she just started to think what exactly might be helpful to actually solve this problem, like the project in itself. She needed something more than that. And she decided that she could at least try to scale and see if she can use something more complex than a pod and actually scale from one pod to multiple pods just to see how this library works and whether it can produce something more complex again. While the pod was really doubting whether that's the great way to do things. So she decided to create a deployment being more like complex object in terms of hierarchy, and it like adds up some interesting features like rolling upgrades for the applications. And also it helps to manage multiple pods or replicas in this case, because it has embedded replica set into this hierarchy, which is another entity like higher up the pod. So if you would look from down to up, it would be the pod, replica set, and deployment, just like that in terms of hierarchy. Replica sets exist just to manage the pods, just to manage their creation, and their embedded nature into the deployment allows to basically manage the pods from the deployment. So in order to use deployment, she also exposed the port from the container, which is going to be useful. Added the number of desired pods or replicas, in this case it's 3. And also she added the same template that she used for the pod because there wasn't anything special that should be used additionally, and hit create on the client. And as soon as she did this, the deployment got created as well as replica set. And also she could see here this declarative nature again, because this desired state being written on the current state. So also as she created the replica set and deployment, 3 pods got created as well. And she decided to try scaling it. So she just retrieved the current scale of the pods in the deployment, which is 3, by defining the name of the deployment, and set up a number of pods she wanted to see now, or the number of replicas in this case, which would be 6. So she tried to update the scale by setting up the name of the object, which would be Nginx deployment, and the upscale for desired scale of pods. And she got these 6 pods, which was great. And also we can see here that we didn't create 6 pods just from scratch. We actually reused 3 pods which we previously created. And that's also the evidence of the declarative nature, because we don't create everything like from the start, from the scratch. We can reuse something as our desired state included 6 pods, and we already had 3 of them, like half of those pods. So Alice got a bit tedious of switching between terminal and Scala code. She wanted to do everything just directly from her Scala code. So she decided to write this very simple function called list pods for actually printing the pods and getting the same information she uses from kubectl get all. So it included some printing, like the name, the namespace, probably the face or status. And the essence of the function would be to retrieve some options from the pod, which include, again, the name, the namespace, and retrieving the face out of the status of the pod, which was also fairly simple, just like getting this entity and getting the parameters or features of this entity. So in order to actually print those pods, she needed to retrieve the list of them, which is in the form of the future of pod list. Pod list is direct type here. And also note here that list and namespace works well in this case because there is only like deployment with 6 pods, while in reality we would have to provide something more specific, because if you would have like multiple deployments running, replica sets, any other objects that spawn pods, we would have like the whole list of pods, while in reality we would want to have something specific to the entity. So she just reused this pods list and called list pods on this on each pod in the namespace, and she retrieved the similar result that she wanted. Basically, she was the most interested in status of the pods and their names, which was excellent because now she could use Scala directly to check on the status of the created objects as well. Also, she created a service because she realized that there should be some kind of a link. So she set this service entity with the name, same labels, because we want to kind of map the service to the deployment, and the port. In this case, it's going to be a node port service because we want our object to communicate outside and not only in the specific like namespace. And then the same create with the service provided allows to instantiate the object. So the service called Nginx we see, which is also quite basic, got created with node port type, with the port being like outward directed because we mapped the local 8080 to 3001, which was kind of an anchor. And Alice was not sure that it's going to help, but she decided to give it a try. It might be not enough to actually save the pod. So this terminal appeared with Nginx as we see writing, and the pod decided to give it a try, so he typed hello. And as a result, he got this who's that answer. So they definitely connected somewhere, but they didn't really know where exactly. So the pod decided to introduce himself. So he wrote his name, which would be MagicDB cluster 0. And as a result, he got this reply like, is that really you? So they realized that probably they connected some way to his home. So it was at least a way to connect. And the pod was really happy, like, oh my God, he could finally talk to someone from home. They kind of invented a messenger for him. But Alice was thinking that if she already got here to creating a way to message this world in some way, what if she could in some way move him directly? So she realized that it was good. It was really great results, but there should be some other way to do that. So she was thinking and she realized that she really didn't know what else she could build. Like she knew all these basic objects, she reused all this knowledge she had, she created the link, and she was already feeling like giving up because she tried a lot of things already, and she was glad that it worked almost straight away. But the pod, he kind of believed in her. So he said that actually Alice could build anything that she wanted because he saw her building things in their world when she just learned to work with Kubernetes objects. So he just said that she could build something that would let him fly back home. And this phrase just clicked. And Alice realized that she knew exactly what she's going to build, and that this idea is quite genius in her opinion. So she decided to work on creating a custom object or custom resource. So a bit of behind the scenes here. Kubernetes has basic objects that we already saw, some of those at least. It's pods, replica sets, and deployments, which work together. Stateful set, which is quite similar to deployment, but helps to manage the state. Daemon set, which works for utility purposes, like gathering metrics, for example, on each node of the cluster. Volume, we saw it just a bit. There are multiple types of volumes. Persistent is only one of those. The service, again, node port is only one type of the service, and the namespace. And more than that, it's not like all of the objects. And for Kubernetes, it works as an API. So there is this basis of an API, but each API can be extended, and custom object in this case is the extension of the API. So she defined this custom resource definition, and it worked in this library with a name and the kind, and that's going to be a launcher. So she created this custom resource definition, or CRD for short, and she created also a service for that called launcher service. So as soon as she did that, the launcher CRD got created, it was running, and they saw that this kind of launcher or rocket got created directly. And it was exactly this thing that was going to work in this case, because here custom object would be like building anything that you want out of extending the Kubernetes API. So Alice was really happy that knowing that this custom object, the rocket that she built, is going to fly the pod home, and the pod was happy as well. And although he spent this time quite lonely in this world, it was still a great adventure for him, because he was pretty sure that no one from his world was able to visit the human world. And it was quite a unique experience. So he was very grateful for that too. And also he hoped that someday Alice would come back to his world and we'll get to see him and others again someday. And Alice was really happy that she succeeded on this project and that she was able to kind of fix her mistake by bringing him back home. So she wished him all the best, and they decided to launch this rocket. And actually it was very small because the pod was small as well, so they didn't really need to get out of the cave. And as soon as the rocket launched, it just disappeared into thin air. So Alice now realized that she could just relax and enjoy her success, but also she could make some conclusions out of this adventure of hers. So first of all, her knowledge of functional programming and Kubernetes in general helped her to build these small steps, going from one step to another, like more and more complex. And this is a great iterative way to build complex things like that. And also, it applies not only to Alice, but to any Scala developer. We can have very basic knowledge and understanding of Kubernetes. It's quite enough to know only the kinds of objects that exist, which kind of object we need to use. We can concentrate on a smaller scale instead of learning like the whole set of objects, why we need to use them. We can try out something more generic. And also knowing Scala, we can create those objects, we can manipulate them in some way, scale them, we can build some watching on their behavior and work with them in a more dynamic way just by using Scala and without the need to switch between terminals. And same as Alice, we can build anything that we want with both Scala and Kubernetes just by having like enough of belief and motivation to learn something that we don't know either from the Scala side or Kubernetes side. So thank you for your attention. I'm going to share the slides on my speaker deck, which is Roksolana D. Also, I'm going to share them in Twitter, and you can check out my GitHub and LinkedIn, and feel free to give your feedback and ask questions. And as I said before, it's a continuation of the previous story, so you can check out the slides for the previous one as well. And hopefully I'm going to create the more and more stories about that by diving deeper into more complex nature of Kubernetes and creating something like a workflow or even something more complicated than that. Thank you for your attention.